Hi everybody, I'm David Peacock in geometry. Bites. So let's talk about vectors. Now, the speed and direction an object moves can be represented like a vector, by a vector like this. A vector is a quantity that has both length and direction. So, for instance, this vector would be named AB. Please note how it's written with kind of like a half arrow on top. Also, A has to be the starting point, B has to be the ending point because of how it is. Even though it looks like a ray, it's not. The arrow shows direction, but not that it continues. Each vector has a starting point and a terminal point. Now, a vector can also be named using component forms. And for this, we're going to end up using what looks kind of like parentheses, but like if we couldn't do curves. You'll see in this next line. The component form of x, y of a vector lists the horizontal and vertical change from the initial point to the terminal point. So in the case of CD that we see right here, we would write 2, 3. The magnitude of a vector is its length. And we actually write it like this. So you might notice that kind of looks like the absolute value symbol outside, but that's how we write magnitude. Now, let's actually try this out. We are going to draw the vector 4, -2, and then find its magnitude to the nearest tenth. So for 4, I just chose a point and I went over 4, and then I went down 2, and that got me to my second point. So if we want to find its length, we go 4 squared plus -2 squared, which if we do that, 4 squared is 16, -2 is 4, so -2 squared is 4, so the square root of 16 plus 4 is the square root of 20. That breaks down into 2 square roots of 5, or if we're going to round, like it says, approximately 4.5. Now, the direction of a vector is the angle that it makes with a horizontal line. So in this case, this would be 60 degrees. Now this measure is angled counterclockwise from the positive x-axis. So the direction of this vector is 60 degrees, like I said. Now note, that means that if I said something like 340 degrees, that would end up being 40 degrees below the line. So we use that. Now, we actually can describe it in another way as well. The direction of a vector can also be given as a bearing relative to a compass directions. So north, south, east, and west. So what you'll notice in this case is it's in between the north and the east. So this is going northeast. So we would write in 30 degrees E. That is vector AB. You could also technically write E60 in, but I don't really see people do it that way most of the time. Now, two vectors are equal vectors if they have the same magnitude and the same direction. So in this case, vector U and vector V would be equal vectors. Two vectors are parallel vectors if they have the same direction or if they are of opposite directions, but they can have different magnitudes. So notice in this case, W and X are parallel vectors because they are parallel lines, but they are not going in the same direction. Even if X was twice as long to where it would actually be the same length as W, because they are going in opposite directions, they would still be considered parallel. Now, the resultant vector is a vector that represents the sum of two given vectors. So if you ever hear the phrase, find the resultant vector, it's basically what happens if we do both of these. So we have two different vectors. So let's try to add these two vectors together. If we want to add up these ones, it's actually a pretty simple directions. So let's move this to the center and do it. Basically what you want to do is you want to have the first vector end and then start immediately at the second vector. Because it would be easier for the red vector to go down than for that blue vector to go up because it would get off of the page, I'm going to just move the red vector down now. There we go. So at that point, what you do is you just start from the starting point of the first vector and end at the ending point of the second vector. So here we go. This is a green vector right there. And this would be our resulting vector. So in this case, it's going 1, 2, 3, 4, 5, and then up 2. Now, we actually can also add vectors numerically, and you simply add the components. So if you wanted to add a vector of 2, 3, and a vector of 5, negative 1, you'd just say 2 plus 5 and then 3 minus 1, which would get you 7, 2. And there you go. That's really about it. If you wouldn't mind, please just like and subscribe. Thank you all very much. Have a wonderful day. Goodbye, everybody.